I think for this question here, you need to use a secondary school concept, right? Which is this concept here, where if you were to draw a line, then this is the angle subtended between the line and the x-axis. Let's say this is theta. The gradient here is tangent theta. Agree? So this is tangent theta here. So now the question now is, right, if theta, now take note, this guy here is an angle. If you tangent inverse 2 is an angle theta 1, then you tangent inverse 2 is tangent theta 2. Okay, so you try to understand this one. So let theta 1 equals to tangent inverse 2 and theta 2 equals to tangent inverse minus half. Okay, what you need to understand is tangent theta 1 equals to 2 and tangent theta 2 equals to minus half. What you need to understand also that tangent theta 1 is actually the gradient of the first line and the gradient of the second line is tangent theta 2, which is minus half. Okay, so that's that. Basically, see tangent inverse 2 as an angle. Then these two are angle. These two are angle. Okay, so that's that. Okay, what I need to, I'll explain M1. I'll just draw to scale because then it's easier to visualize, right? Considering two lines here. So this guy here is 2 and 1. The gradient here, M1 will be 2, right? So this is theta 1. This is theta 1, right? So if you have a rise over run, your rise is 2, your run is 1. That's theta 1. Theta 2 will be, is negative. So this guy here will be here. So if theta 2, you are looking at this line here. We draw to scale. So this guy will be M2, which is equals to minus half. See that? Theta 2. Right? What I'm trying to say that is this is 90 degrees, because theta 1 minus theta 2, this is 90 degrees, right? So you can say that since M1 multiplied by M2, which is 2 multiplied by negative half, this is negative 1. Clearly, theta 1, the angle between theta 1 plus modulus theta 2 is pi over 2. Cos theta 2 is a negative angle. Understand? Theta 2 is a negative angle. So essentially, if you open up the modulus, right? You open up the modulus, this guy here would be minus theta 2. Because if you want to make it pi over 2, actually, this will be minus. Minus will be plus. So then hence, because tangent 1 is tangent inverse 2. Right? Tangent inverse 2 minus tangent inverse minus half pi over 2. Okay. I don't think you need to write until so strict lah. Like I think this line here already be as long as you can show that this is 90 degrees, it's fine. But I just write it down because that's that lah. I just write that like that. But you don't really need to open up the modulus if you're not comfortable. It's fine. Okay, let's look at part 2. Find a set of value of k such that these two intersect. I think this is pretty okay. Now take note, k has to be more than 0. So I'm going to let k be more than 0. Take note now, k is more than 0. So let c1 equals to c2. So x squared plus 1 equals to k 3x plus 4. Cross multiply. 3x plus 4 equals to k x squared plus 1. Then this is discriminant, right? 0. kx squared minus 3x plus k minus 4. 0. So if they intersect, if there's a real C1 and C2 intersect, means that the real solution. In other words, what we need is b squared minus 4ac at least 0. Then what we do is just minus 3 squared minus 4k, k minus 4. Solve this quadratic inequality for k. Expand it out. Minus 4k squared plus 16k. 9 again 0. Don't keep this as negative. So multiply by negative throughout. Okay, then try. Remember to flip the inequality. Then factorize it, should be quite okay. 2k plus 1, 2k minus 9 less than 0. From here, draw the number line. Negative half and 9 over 2. So what we need is here to here. Okay. But what you need to understand is also and k has to be bigger than 0. So hence, you have got this is 0. Just here to here. Okay, the solution that you're looking for. So we just minus half between k, 9 over 2, and k bigger than 0. So if you overlap them, it will be k has to be bigger than 0 and at most 9 over 2. So for part 3, sketch C1 and C2 with k is 2. I think this is pretty okay. Any asymptotes you need to write it down. Process the axis and so on. Okay, great. Just read. So this case here, for this guy, we know that when x goes to infinity, y will equal to 0. So the horizontal asymptote is y equals 0. This guy, similarly, the horizontal asymptote is also y equals to 0. But the vertical asymptote, the bottom cannot be equal to 0. So x is equal to minus 4 over 3. Okay. You don't have a real root for the denominator. So for the first one, very likely, it's actually, you don't have the vertical asymptote. But you key in calculator, you'll be able to tell. I'm going to key this in. 1 over x squared plus 1. The other guy will be 2 over 3x plus 4. Draw it. You get this graph here. So obviously, I will always suggest you zoom box. Okay, don't underutilize the graphing calculator space there. Just zoom to this area and sketch this curve here. Okay. Okay, so just label everything out. This will be y equals to 2 over 3x plus 4. X 0. Then this would be our y equals to 1 over x squared plus 1. Okay, this will be 0, 1, which is the maximum point. And y equals 0 is the horizontal asymptote, then x equals to negative 4 over 3. Then we have got here 0, half. Okay, just key in calculator. I think all these points we will be able to find it. Similarly for the intercept, I don't think they need it, but you can draw it out if you want to. But I think it's important for the next one. You can just key in intersect. Just find a intersect here. So this is minus half. So this is actually minus half and 4 over 5. Then this guy here will be just key in calculator, intersect. Two and 1/5. Okay. Finding the area bounded by the two curve exactly will be this curve here. This area here. Take the top curve minus the bottom curve, right? Then just integrate. That's about it. So the top curve would be here will belong to this 1 over x squared plus 1. Then the bottom curve is the reciprocal graph there. So just try to part 4. So required area. Okay, that's why the boundary is important here. From minus half to 2. Negative half to 2. Top curve minus bottom curve. So top curve is 1 over x squared plus 1 minus of 2 over 3x plus This is okay. This is just tangent inverse. X from F26. This will be ln 2 third 3x plus 4 to a negative half. Just key in calculator. So this guy with tangent minus 2 third ln. They want the exact value, right? 6 is 10. Tangent minus half minus 2 third ln minus half times 3 plus 4. That will be 5 over 2. Okay. Exact value. Exact area. So I think for the first part, that's why this is important. This will give us tangent inverse 2 minus tangent negative half. So this guy with tangent minus 2 minus tangent minus negative half minus 2 third ln 10 plus 2 third ln 5 over 2. So this guy from the first part, from 1, is actually pi over 2. Okay. This guy can factorize the negative 2 third out. So this guy will be ln 10 minus ln 5 over 4. 5 over 2. 5 over 2 minus 2 third using logarithm quotient rule. 10 over 5 over 2. Okay, so once you're done, this will be pi over 2 minus 2 third ln 4. Okay, you can simplify this, or you can leave it like that. This is already exact, but you can just simplify this as 2 square. So this guy will be pi over 2 minus 4 over 3 ln 2 square units. Okay, so this is the required area.